Okay, so the first chapter of this course, which was supposed to be first, but they start the course with chapter 6, which is some descriptive statistics. You have already taken 80% of this chapter in ISC 291, but in a different perspective. There you rely heavily on software. Here you will learn how to find all those measures manually by hand. So the chapter is basically descriptive statistics. The word descriptive comes from describing. So you describe the data. Now, when you are describing the data, you can describe many aspects of the data. You can describe the center of the data. You can describe the variation in the data. You can describe the skewness of the data. You can describe the kurtosis of the data. There are many ways of describing the data. What we will learn in this chapter is some numerical summaries of the data. One of the ways of describing the data is through numerical, and another way is through graphical. So you will study some numerical descriptions and some graphical descriptions in this chapter. The first section is about some numerical descriptions. The second section, stem and leaf plot, this is a graphical description of the data. The frequency distribution and histogram is again a graphical representation. Percentile, which is a supplementary concept for the box plot. Box plot is again a graphical, but we need to discuss what are percentiles before jumping into box plot. Now, this box plot you have already taken in 291. Histogram you have taken in 291, but there in 291 they gave you the wrong terminology. They tell you that the histograms are of two types. One is for numerical data, one is for categorical data. No. For categorical data, you call it a bar chart. It's not called histogram. Histogram terminology is specifically reserved for numerical data. Histogram, if you see the histogram, its boundaries are joined. The bars are joined, which means it's for the numerical continuous data. The bar chart, you will see there will be a bar, then there will be a gap. Then there will be a bar, there will be a gap. That's for categorical data, where you have the categories. For example, red, green, blue, and so on. So there will be a bar for the red. There will be a bar for the green. Inside the two bars, there will be a gap. That's bar chart, nothing to do with this course. Put your mobile in the pocket. Mobile in the pocket. Do not take out the mobile throughout the class. If you want to use the tablet, feel free to use the tablet, but no use of the mobile during the class. So these are the four concepts basically. The fifth section that I made in the slides, this is a supplementary section for the box plot. This is 6.1 in your book, 6.2 in your book, 6.3 in your book. This is 6.4 in your book. The one I made here for section 4 is supplementary for the box plot. Before jumping into the box plot, you know box plot relies on Q1 and Q3. So to get Q1, Q3, I need to discuss the concept of percentiles. Let us talk about some of the key numerical measures. When you describe a data, there are few aspects of the data that you need to describe. How to get it up? Okay. There are few things about the data that you need to describe. One of the aspects of data that you need to describe is the center of the data. There are many measures that describe the center of the data. Few of them that you will study in this course are the mean of the data. Mean describes where is the center of the data. The median of the data. Median also tries to locate the center of the data, but in a different way, using not the magnitude of the values, but the center location of the values. Mean uses the magnitude of the values. Median uses the location of the values to locate the center. Mod uses the frequency of the value to locate the center. But all of them, they correspond to the measures of central tendency of the data. Where is the center of the data? Then Center is not the only thing to be explained in the data. Center cannot explain all the data. Let me give you an example. Let me give you an example here. Where is the pen? Center cannot explain everything about the data. Let me give you an example. 1, 2, 3. This is the data set. 0, 2, 4. This is another data set. What is the mean of first data? 2. What is the mean of second data? 2. They have the same mean. Are the data sets same? No, the data sets are different. That means there is more in data set than only the center. Only the center does not describe the whole data. There are more things. What is different between these two data sets? The mean is same. The amount of variation around the mean. In the first data set, the values are closer to the mean. In the second data set, the values are far from the mean. So the variation in the values around the mean or around the center is different. So the second aspect that we need to study about the description of the data is the amount of variation, the amount of variability in the data. And there are many measures for that one also. One of the most popular measures to study the variation in the data is the sample variance, which is the average. When you divide the number by n, that is what? When you divide the sum by n, it gives you average. What is the average? You divide the sum by n. So this variance is basically an average. Why am I dividing by n minus 1 and not n? I will answer this question later in chapter 7. But it's the number divided by, it's the sum divided by the number. So sample variance is average. Average of what? Not average of x. It's the average of, it's the average of what? Squared distance of each value from the mean. Squared distance of each value from the mean. How far is each value from the mean? You take that distance, you square it. Why do you square it? So that negatives do not cancel the positive values. That's why you square it. You can take even absolute. Absolute is called another measure which you do not study in this course. That's called mean absolute deviation. You do not take it in this course, but there is another measure which taking absolute. So this x minus x bar tells you what? How far is the value from the mean? If it is positive, that means it's above the mean. If the value is negative, that means x is below the mean. Then if you simply add them without taking square, what will happen? What will happen? The deviation of 0 from 2 is minus 2, correct? The deviation of 4 from 2 is plus 2. This plus 2 will cancel minus 2 and you will end up with 0. Well, you know that there is not 0 variation in this data. There is variation in this data, right? So to avoid that cancellation of positive from the negative, you take the square. Once you take the square, the overall measure becomes the average squared deviation of each dividing by the number, squared deviation of each value from the mean. That's variance. Now, the next thing is, if you have the variance, why is there a need of standard deviation, which is just the square root of variance? What new thing standard deviation is telling you in the presence of variance? You see the formula of standard deviation? It's just the positive square root of variance. What new thing is it telling you? Why am I giving it a special name, standard deviation? I have the variance. Magnitude of the variance, you will have the number here.
I think because we have squared variance, to remove the effect of the square, we use the standard deviation.
Yes, up to some extent. What is the unit? Let's say your x is the height of students. Okay. What will be the unit of x in this case? Centimeters, let's say. What will be the unit of x bar? This x is centimeter. If you add centimeter plus centimeter plus centimeter plus centimeter, the result is, if you divide centimeters by a unitless number, the result will be, if x is centimeters, x bar will also be centimeters. Clear? Now turn towards the variance. This X is centimeter. X bar is also centimeter. Can you take the difference or sum of two numbers with the same unit? Only same units you can take. Otherwise, you cannot, the sum or the difference will not make sense if the units are not same, right? I cannot add your height into your salary. It will not make any sense. Your height plus your salary. Height is centimeter, salaries is dollars. It will not make any sense. You can only do the sum if the numbers are same units. Now here, X minus X bar will be what unit? Centimeter minus centimeter is, then you square it. What's the unit? Centimeter square. Then you sum many centimeter squares, centimeter square. Then you divide it by a unitless number. So the unit of variance is squared the unit of original variable X. That means your amount of variation is not in the same unit as the original data. This is one reason of taking the square root. The second reason, later you might see some of the identities to identify the outliers. X bar plus minus 3 standard deviation and so on. Can I add variance in X bar? Why? Same units, missing same units. So I cannot do this thing with the variance. You see the bands later I will make in chapter 7 or 8. I will make the bands to detect the presence of outliers. One of the ways is to box plot. Another way is this standard scalar to identify the outliers. So you cannot add variance into mean. That's why we define a new measure, which is not contributing in terms of theory, but its contribution is in terms of the units. It brings you back to the actual units of the data, which is what we call the standard deviation. And then there is a third measure of variation, which is called the sample range. This is the simplest among all, which is nothing but the difference between the maximum value and the minimum value, which is sample range. Now, what do we expect from you in exam? From you, what we expect from you is to understand these measures, what they mean to our data, and we expect from you how to calculate these measures by hand. In lab, we expect from you how to find these measures on RStudio. So you will learn how to get these on RStudio using a data, and you will learn how to compute these by hand here. Now, in most of the questions you get in exam, we will give you a data, and along with the data, we will give you mostly, not always, but most of the times, we will give you this, and we will give you this. Most of the times, if you open the old exams, you will see that they give you the data, and then they give you the sum of the data, and they also give you the sum of square of the data. They will give you the sum of the values. They will also give you the sum of squares of the values just to save your time. At this level, at the university level, we do not expect that you don't understand how to take the sum of 10 values. So that's why we give you the sum. We give you the sum of square also. Even if you make a mistake in this sum and sum square, that does not mean you have not understood. This might be some typing mistake on the calculator. So usually you will see these numbers are given. You just have to plug these numbers into the formulas. In your formula sheet, what formula is given to you for mean is this. For variance is this. Standard deviation is not given. You have to understand that it is just the positive square root of the variance. Range is not given. You need to know the range is the difference between the maximum and minimum. Median, the direct formula for median is not given, but the formula for percentile is given. And median is one of the percentiles. And I will let you know which percentile is median and how to find the median. So these are the 6 measures that I will talk about today. Any question about these measures? We can give you direct question or we can give you indirect question from these measures. For example, I can tell you that the mean is 7. These are the 10 values and I ask you one of the values is missing. I give you the mean and ask you to find that missing value. I give you that 9 values and the 10th value is missing. I give you the mean is 7 and ask you to find that 10th value. Or I can just give you the 10 values and ask you to find the mean. Direct question or indirect question. So both ways is expected. We will solve that on Thursday. Many questions. Let us have a simple problem. This is from your book. The problem says that the pull of strength for 8 prototypes, these are the values. Okay, they are in pounds. The unit is pounds. we have to find the mean, median, mod, standard deviation, variance, and range for this data. As I said, the summary of the data is given. The sum of x is given to be 104. The sum of x square is given to be 1353 point something, and n is given to be 8. Correct? These are few numbers that you need for computing all of those summary statistics. So for x bar, what do you need to do? Just divide the sum of x by n. So 104 divided by 8 comes out to be 13. So the mean is 13. How can I interpret this 13? The average pull of force for the prototypes is 13. What is the median of this data, which is not here? And I don't think I covered it here. Yeah, let's find it manually. How do you find the median of this data? The median of this data, if you look at the formula, the median has to be found in 3 steps. The first step is to arrange the data in ascending order. This is where most of the students, they make mistake. If you don't arrange, you get the wrong median. So let us find the median. The first step is to arrange the data in ascending order. Which is the minimum value? 12.3 is there, 12.3. Then another 12.3? No, 12.6. 12.6. 12 point what? 9. 12.9. 13.1. 13.4. 13.5 and 13.6. Okay. So suppose this is the arranged data. Okay. Now, once you have arranged the data, the median is n plus 1 by 2th value in arranged data. What is n? 8 plus 1 by 2. What is 8 plus 1 by 2? 4.5th value. Now, in some data sets, n will be odd. This number will come out to be a whole number. And in some cases, n will be even, and this number will come out to be a fraction. If this number comes out to be a whole number, you just go and pick that number. That will be your median. For example, if 4th value is median, 12.9 will be the median. The second mistake students will make is student will report 4.5 to be the median. 4.5 is not the median. 4.5 is the rank of the median. Okay. The median is this 4.5 value. Now, how do we find this 4.5 value? This is found using the interpolation method in your course. This is basically 4th value plus 0.5 times 5th value minus 4th value, which is actually just going in the middle of 4th and 5th, but I'm preparing you for the percentiles later. So just go to the 4th value. What is the 4th value? 12.9 plus 0.5. What is 0.5? 0.5 is this 0.5. This 0.5. 0.5 times what is the 5th value? Minus 12.9. So this will be, I think 13, is it?
Yes.
Yeah. So the median of this data is 13. What is mod? Yes. Yeah. In this case, the median is just the average of 2. But again, I'm preparing you for a general case percentile where this fraction is different from 0.5. Later, I might ask you for a 70th percentile. In that case, this one will come out to be maybe 4.75th value. In that case, it will not be the average. So this is general formula for specifically median. Yes, it will be the center of the two. Now, what is the mod of this data? These are few comments that you need to know about mod. Number one, mod is the most frequent value of the data. According to this definition, most frequent value of the data. You can have a data with no mod. If 12.6 was not repeated, you would say there is no mod. You can have multiple mods. Let's say there is another value in the data. Let's say if the last value was 13.5 also. In that case, you will have two mods, 12.6 and 13.6. Now let us move on towards the computation of variance. For variance, again, this is the formula that we will give you in exam. Which means for variance, first you need to find the mean. You already found the mean to be 30, right? So just plug in everything into this formula. 1353 point something minus what is n? 8 times 13 square, which is 169, divided by 8 minus 1, which is 7. Everything on the calculator, so make sure you are comfortable with your calculator. Put everything into the formula, 1353.6 minus 8 times 169 divided by 7. And this is the answer for the variance. Now, usually we do not interpret this guy, we interpret this guy. This is the average deviation of each point from the mean. This is the average square deviation of each point from the mean. Usually we don't interpret this one. So the standard deviation is the positive square root of this number. One thing to be careful of, we will give you repeated reminders in exam to round it to minimum 4 decimal places. So all the slides you will see, I will prepare you for rounding up to 4. Do not round to 3, do not round to 2, do not round to 1. Any question, if rounding is required, round it up to 4 decimal points. So I rounded this one to 4 decimal points, it's 0.2286. And the standard deviation comes out to be 0.4781. I repeat, on average, each value in the data deviates from 13 by a magnitude of 0.4781. The average deviation of each point from mean, which is 13, is 0.4781. What is the range of this data? 1.3. 13.6 minus 12.3. 6.2, stem and leaf diagram. The stem and leaf diagram is a graphical way of summarizing the data. Throughout this chapter, you are actually trying to compress the data to present it to the business person. You cannot give 7,000 values to the business person, so you're trying to compress. One way you're trying to compress, and on the other side, you are trying to retain as much as you can. Too much compression is not too good. Too less compression is not good for presentation. Too much compression is not good. That means you cannot get the data back, right? So you're trying to be somewhere in the middle. Compression, but not too much compression. I will explain it to you in more detail. What is more compression? Now, here, this is a diagram where you try to summarize the data, but you retain the original data also. You don't lose the original data. What you do is this type of diagram is only possible if you have the data in 2 or more than 2 digits. If the data is 2 or more than 2 digits, this kind of diagram is possible. What is this diagram? It's a graphical representation that splits the data into stem. Some part of the value will be called stem, and some part of the value will be called a leaf. For example, if your data is 2 digit, for example, 76, 79, and so on, the tens part, we will call it stem, and the ones part, we will call it a leaf. So each stem will become a class. With respect to the histogram, you have bins, right? So each stem will be considered as a bin. And against each bin, you will have many leaves. In 70s, you will have many numbers. So the diagram at the end will look like this. The original data was the compressive strength in PSI, and the values were 105, 121, 158, 143, 167, and so on. There were 80 values in the data. What we did by looking at the data, we decided the first 2 digits to be stem and the third digit to be the leaf. So we looked at the data. The data started with 76. So the first stem came out to be 70. 80, 90, 100, 110, 120, 130, all the way up to 240. Now, in 110s, there were three values in the data. One of them was 115, one of them was 118, and the third value was 110. Where is this 105 in the data? It's here. Can you see it? Can you see it? Where is this 121? 121. Here it is. Where is this 167? 167. Here it is. Right? There is two? No, there is one. Yeah, there is another 167. Yes, there are two, and so on. And the last step is the important step is to mention the unit of stem and the unit of leaf. Here, this 7 means what? 70. So we say the 10 and 100 digit is the stem, and the 1 digit is the leaf. Yes. No. Yeah. It does not have to be ordered. It does not have to be ordered. Now a question. If I give you the stem and leaf, can you give me the data back? So there is compression, but not too much compression of the data. I can get the data back. You're presenting it in a nice way. Here you present it in a nice way. What is a nice way? You can see where is the average of this data. It will be around here 150, right? Where is most of the data? Between 140 and 160. You see the frequency here? 8, 12, 10, and 10. So you are actually getting insight of the data, but without losing anything from the data. Yes. Yes, it's the frequency of the stem. In 70 stem, how many leaves? It's the number of leaves. In this 80 stem, how many leaves, and so on. So it tells you about the central tendency. It tells you about the shape of the data. What kind of shape is this? It is symmetric shape, the normal shape. You see the shape? Just turn your heads like this, and you will be able to see the shape of the data. You see the shape? Let me turn, instead of your heads, let me turn this. No, I cannot. I cannot. Just turn your heads like this, and the classes will come at the x-axis and the frequency will come at the y-axis, and you see it like a histogram. When you see it like a histogram, you'll be able to see that it is a normal distribution type of curve, symmetric type of shape, where the majority of the data is in the center and the tails are lighter than the center. Again, the good thing about this stem and leaf is retains the original data. If I give you stem and leaf, you can give me the data back. If I give you a histogram, can you give me the data back? Histogram will tell you that between 150 and 160, there are 7 values. What are those 7 values? You don't know. You don't know what are those 7 values. So you have some idea about the data, but you lost some information about the data while making histogram and frequency distribution and so on. This is not true with stem and leaf. Stem and leaf, you retain the original data, but again, you try to compress it for the good presentation in front of. So what you do is you divide each point into stem and leaf. You list the stems in the ascending order on the first column. Then you write the corresponding leaf besides each stem. And then you, at the end, an important point that we usually miss is to indicate the unit of stem and unit of leaf. Again, if I do not give you the unit of stem and unit of leaf, can you give me the data back? You cannot. You don't know if this is 70 or 7 or 700. 7. So you only know this is 70 if I give you the unit this is tens and hundred. This can be 1400. This number can be 14200. Can be in hundreds. Stem is 100. The leaf is 100 and the stem is thousands. I can make a stem and leaf of that one also. So unless you provide this last line, you cannot have the data back. So the last step is very important to mention the unit of stem and the unit of leaf. The unit of stem here is actually 10. This 11 means 11 times 10. This 20 means 20 times 10, 200. The next compressing technique, again, a graphical technique, is called a frequency distribution. This is done to make a histogram. The objective for making frequency distribution is to create a histogram. Now, how do we make a frequency distribution? To make a frequency distribution of the data, we have 4 specific steps. The first step is to find the range of the data. So suppose I have a data here. Let me take a hypothetical data. 2, 4, 7, 3, 4. Six. I think we'll keep having this problem. For this data, let's go to the step number 1. What is step number 1? Determine the range of the data. What is the range of the data? 15 minus 2, which is 13. Step number 2. Now, from exam point of view, we might give you the number of bins, or we might ask you to compute the number of bins. If we give you the number of bins, you do not use this formula. Just use the same number of bins that we give you in exam. For example, we ask you to make a frequency distribution of this data with 5 bins. Class, we give you 5. No need to use this formula for the number of bins. Okay. If we don't give you, this is the rough approximation for the number of bins, which is the square root of n. So what is your n in this case? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What is square root of 15? Let's make it 4. Approximately 4. So suppose there are 4 bins that you have to make. Calculate the width of each bin. So divide the range by the number of bins. So divide the range by the number of bins. What do you get? 3 point something. Round it up. Make it 4. Why round it up? I will show you at the end of making frequency distribution. If you round it down, you might end up with 5 bins. If you round it down, you might end up with not number of required bins. You require 4 bins, right? So if you round it down, you might end up with more than 4. And start making the bins from minimum or close to minimum of the data. So the bin size is 4. Let's start making the bins. Yes. No. If we give you, we will give you. Just take that number of bins. Let's say the question says make a frequency distribution with 4 bins. Alas, you take 4 bins. No. The n is not the notation for a number of bins. N is the notation for number of values in the data. Okay. N is the number of values for the data, not the number of bins. Okay, so let us start making classes. For making classes, you start with, let's say, 2. What is 2 plus 4? 6. What is 6 plus 4? 10. 10 plus 4? 14. 14 plus 4? 18. That's it. These are the bins. Okay. Then go value by value. What is the first value? 2. What is the second value? 4. What is the third value? 7. What is the fourth value? 3. What is the fifth value? 4. What is the sixth value? 4. What is the seventh value? 7. 3. 9. 11. 4. 2. 7. 15. 6. So what is the frequency? 5 plus 3, 8, 5, 1, 1. So this is called a frequency distribution. The middle column is only for my convenience to take a record of the data. Usually we will not ask you to do this kind of activity in exam. This is long. Let's say we give you 80 values. This will be a very long activity. But this is how we do it. The middle column is called tally bar. We used to do it back in when I was doing BS in 2005 and 6. We used to do this with hand. Now you have the computers to do this for you. So this is called a frequency distribution. From this frequency distribution, you make a histogram. How do you make a histogram? You take the bins at the x-axis. There is 2, there is 6, there is 10, and there is 14, and there is 18, right? And the y-axis will be the height of the frequency of each class. So what is the frequency of the first class? Let's say this is 5 and this is 10. So from 2 to 6, you have 8 values, 5 values, 1 value, 1 value, and this is called a histogram. This is similar to stem and leaf. Stem and leaf is this way, this is this way, this is similar to stem and leaf. But if I give you this frequency distribution or this histogram, can you give me the data back? No. But in this case, in stem and leaf, if I give you the stem and leaf, can you give me the data back? Here you can, because you know there are 8 values between 2 and 6, but you don't know what are those 8 values. Yes.
Finding the width for each bin, you always round up?
Yes. Now, see, if I round it down to 3, what will happen? My classes will be from 2 to 5, 5 to 8, 8 to 11, 11 to 14. Now, you have already 4 classes, and there is a value in the data which is 15. So you need to make another class here. So you ended up with 5 classes. If you round it down, you might end up with more classes than the desired number of classes. There is no such rule for that one. You can round it down or round it up. This is a very, very, even in the notes, look at this one. There is no specific rule, but there is a specific rule for this one to always round it up. If you round it down for the number of the width of bins, you might end up with more bins, but there is no hard and fast rule for the number of bins. Most of the times we'll give you the value. 7 bins, 8 bins, 5 bins, and so on. And this is not the only rule. In book, you will see there are many rules. One of them is square root of n. Only one of them is square root of n. So here is an example of a histogram. In this histogram, what is the shape of the data? Symmetric, symmetric, symmetric. What is symmetric? No, normal is one of symmetric, but there are many other symmetric. This is normal, right? Is this normal? But this is symmetric. What is symmetric? Image of the left side of the center. Normal is one of examples of symmetric, but there are many other examples of data being symmetric. Symmetric means that the left side is mirror image of the right side. Normal is one of the examples of symmetric. This looks close to normal also, right? What does this histogram tell you? Most of the data, one is symmetric. Most of the data is between 130 and 210. Yes. What else? Does it tell you about approximate center of the data, mean? What is that? Probably around here, 150 and 170. Roughly, you can say 160. What else? For the normal distribution, yes. Mathematically, yes. What else can you get from this? Yes. Yes, you can guess about the range. Roughly speaking, the range is 250 minus 70. The minimum value not necessarily 70, but it is between 70 and 90 somewhere. Yeah, so approximately the minimum is 70, the maximum is around 250, less than 250 or equal to maybe 250. And I think this is it. Now let us move on towards percentile, a general concept. Before I move into this general concept, what does your median do? Your median splits the data into two equal parts from the middle. Median is one value that splits the data into two equal parts. What are quartiles? These are three values, not a four parts. Yes, these are three values that split the data into four equal parts. What are percentiles? These are 99 values that split the data into 100 equal parts. So from graphical point of view, if you have this data, this will be median. Split the data into 50% left, 50% right. So let's say if I tell you that the median is 13, what does that 13 mean? 50% of the values in your data are less than 13 and 50% values in your data are more than 13. What are quartiles? They divide into four equal parts, 25%, 25%, 25%, 25%. If I tell you that Q1 is 7, what can you say? Let's say this is 7. 25% of the data is less than 7, whereas 75% is more than 7. What is Q2? Same as median. What is Q3? Third, the 75th percentile or third quartile, which means that 75% of the data is below Q3 and 25 is above. Yes. Usually we don't care about the equal part, but if you are interpreting it for a discrete data, we say that probability of X less than equal to Q3 is 0.75. Equality lies with the quartile, usually, but for continuous data, it doesn't matter. Again, I did not get the question.
Of the difference between Q1 to Q2, of the number inside.
Not the number, the percentage of the data. We are saying that if you have 100 values in the data, 25 values will be below Q1, 25 values will be between Q1, Q2, 25 values will be between Q2, Q3, and 25 values will be between Q3, above Q3. There is no Q4. And this is where your box plot comes into the picture. You remember? You make a box out of Q1 and Q3 and extend it to Q3 plus 1.5 times IQR, Q1 minus 1.5 times IQR. What is IQR? Interquartile range, the difference between the upper quartile and the lower quartile. Q3 is called upper quartile, Q1 is called lower quartile. Let you go at this point. I will continue from here in the next class. Next class, I will finish chapter 6 in 10 minutes and go toward the problem solving. Be on time in the next class. I will take attendance. Yes, tomorrow when the registration closes, I will add you to a Microsoft Teams. So from tomorrow onwards, you will have the access to recordings. You will have the access to this OneNote file, and you will have the access to everything that I do in this class.
Do you use platform or just the message?
Oh, all of them. I will post it on the Blackboard also.
Because